You open this door with the key of imagination. Beyond it is another dimension. A dimension of sound, a dimension of sight, a dimension of mind. You're moving into a land of both shadow and substance, of things and ideas. You've just crossed over into the Game Dev Zone.
What a stupid intro. This devlog is all about floors and ceilings. It's a real adventure. Starting off, I had unearned confidence, and it was all going to get shattered by the end, and then built back up. The game wants textured floors and ceilings. It's just calling out for it. It doesn't want solid colors for the floors and ceilings. I started off trying to do all the texturing in software. It took a lot of work to figure out the math and what mistakes I was making. Eventually I did get something working, but it's slow. And we aren't even thinking about drawing other sectors or floors. But besides that, I was happy with myself at least. I had something working. A few days later when I came back to it, I wasn't happy anymore. Slow isn't fun, and I wasn't even drawing floors yet. Software rendering is too slow. We need hardware to speed this up. This is where I ran into conflict. I certainly could set up a 3D camera and add objects to the scene. Raylib has plenty of tools for this, and OpenGL would render it with no complaints. But where's the fun in that? My design goals are: number 1, fun for me to program. Number 2, seems like a stupid way to do it. Number 3, fast enough. Can we carve out the OpenGL tools we want to speed up the floor rendering while doing stupid things? Yes, and I have found a way. Shaders. Shaders are cool little programs your GPU can run. They're really cute and fun and also cute. From my limited knowledge, you at least have 2 types of shaders, fragment and vertex shaders. There could be more, but not less. There's not less of them. Vertex shaders modify the 3D objects, vertices, I think, and fragment shaders control the fragments, basically the pixels, that get drawn to the screen. We don't care about the vertexes that get drawn, so they can fuck off. Raylib will handle those. But what really sounds appealing is those sick fragments. If we can finagle a fragment shader to do our floors and ceilings, we might be in business. Raylib has built-in code for messing about with shaders, so I tried to take my current ceiling and drawing code and modify it for the fragment shader. After some fiddling and tweaking and crying, it works, kinda. I still need to draw floors and other sectors, but it's much faster. Speaking of drawing other sectors though, let's do just that. Hey, that looks pretty nice. But there are issues. The ceiling of one sector might draw over the ceiling of another. I need to find a good way to tell the ceilings when to stop drawing. I've fiddled around with a few ideas that are stupid, like sorting the ceilings back to front or front to back or one way or another, or finding out what the Y range on the screen should be for the ceilings and only draw in that area. Each of my ideas had weird quirks and rough edges, even if they mostly worked. Then I discovered stencil buffers. If you're less sophisticated, like I was 1 week ago, and don't know what they are, a stencil buffer is a way to mask out certain regions of the screen. From there you can draw in only that area, or not that area, or a few other things. Crucially for my use case, I can set the area that my ceilings are able to draw in and mask out the area an adjacent sector can be drawn. Let's see how I did it. First, I tell OpenGL that I want to use a stencil buffer. Then when drawing a sector, I draw normal walls. But when I draw that wall, I tell OpenGL to only draw a wall where the stencil buffer is 0, and if it was able to draw a wall, set the stencil buffer to 1 where it drew that wall. Now I have a space where I can draw ceilings without drawing over my walls. I draw the floors and ceilings. But there's still that slight issue of ceilings drawing over other ceilings in adjacent sectors. There is a solution, And since I wrote this script and you didn't, I knew what was coming next. Portals to other sectors. Portals to other sectors are just walls, but they shouldn't be drawn. But I quote-unquote draw the portal walls to the other sector. And what I do is I change up my stencil drawing instructions to OpenGL. I go over to OpenGL and I tell it, hey, wherever I draw this portal, set the stencil back to 0. But also, between you and us, don't actually draw the portal. It's just going to be for pretend, but do update that stencil to 0. OpenGL is pretty cool, and it does it. Now the stencil buffer has 0 set, where the adjacent sector should draw. Now I can draw our adjacent sector with the same algorithm, but it is constrained by the stencil buffer to draw only where it should. Neat. We fooled GL into doing what we wanted without having to give it any vertexes or meshes or matrices or cameras. Maybe Raylib gives it that, but I don't care. It's stupid, and it was fun, and it is fast. It ticks all the boxes. There are a few issues with my current implementation, but nothing my code slave whose labor I exploit can't solve. That's it for this log. Next time I want to improve the entities in the game and possibly asset importing and animations. If you want to see something else cool, go check out this other project I've worked on called QExporter, link in the description. I'll be using it more in these devlogs as time goes on, but for now, it's a neat tool that you can use to mass export your assets into a texture atlas. But even better than existing tools, it allows you to set metadata like tags and define animations for your assets in one place. All that data gets exported to the data file along with your texture atlas, so you can do it all in one program. And an upcoming feature is to add regions to your assets. For instance, to define points where a sprite's weapon should attach to its hand, or hitboxes for your sprite. Thanks for watching.